particular part we already discussed. Now again we'll going to do one kind of revision what we have seen in previous lecture. We have seen the different definitions of Internet of Things, which is given by the different renowned companies, specifically in the domain of cloud, isn't it, or in the field of internet connectivity, isn't it, or in IoT. We have also discussed what are the actually pillars on which this IoT technology is built into. Okay, not only that, but also we have seen the structure of the IoT. Okay, so it's a tagging, filling, shrinking, and thinking. Without these four properties, IoT will not be successful, isn't it? It should have these properties, and then only IoT can be utilized in any kind of applications. We have discussed also one simple block diagram, how the devices can communicating with each other and floating the data into the IoT gateways, and IoT can upload the data onto the cloud, and depends on the requirement we can use any device. Okay, take an example, these mobile phones and PC or any kind of smart devices, so that we can able to access the stored data onto the cloud. Okay, next one, we have seen the IoT architecture also and the layer structure. Today we're going to discuss in details about it. We have also seen the IoT components. What are the major IoT components available from the source side towards the application source? Now, if I'm talking about the first, what is that thing? The thing is nothing but any kind of smart device which is capable of having all the four respective properties, isn't it? The tagging the things, we can have the thinking the things, shrinking the things. Okay, everything. Your device should be connected to the local network first, isn't it? It should be connected to the local network, so that it will be able to share the data first locally, and after that to the globally using the internet connectivity, isn't it? So local network also called as, yes, can anybody write in a chat box? Local network also called as. I have said one proper kind of nomenclature for that particular local network in previous class. Just like an internet, we have certain name to the local network. Can anybody write in a chat box what was that name? Or what is that particular name? Remember? Yes, no? Yes, no? Write in a comment box, yes or no. Intranet, very good. Sanand Joshi, very good. It's the intranet. So we have discussed again the difference between intranet and the internet. Intranet is a local network through which devices are communicating with each other. That doesn't require any kind of IP addresses. Sometimes they are only working with the MAC addresses, isn't it? Because every individual device is having a unique MAC address, also called as physical address, which is given by the manufacturer while designing that particular component, isn't it? So with the help of devices MAC address, we can easily communicate. That is a hop to hop communication or node to node communication. Also a point to point communication, means your sender to receiver communication. There are varieties of aspects are there, okay, or the nomenclatures are there even in computer networking, but also in IoT domain also. We can call the device as a gadget, node, then we can have the computers, your mobile phones, we can having your hops are nothing but again device or any kind of points. Got it? So these are the local network, and internet is a kind of global network. So if we are having a local networks, if all such local networks are connected together with the help of internet service providers, ISPs, isn't it? And a huge network will be formed, and that will be called as an internet. So internet is the abbreviation of internetworking, isn't it? And we are going to utilize these contents with the help of certain applications, and below every application, once you open any application, there are enormous processes running behind it. Okay, so we needed certain interface levels also, APIs, application program interfacing, isn't it? Certain processings are required or processes are required to run these particular application effectively. So these are one of the important concept or the IoT components of your IoT domain. Now next we'll talk about one example, how actually the flow from source to the destination and from destination back to the source, isn't it? Because we need to establish the session, we need to upload the data, not only uploading the data, we need to get the data back from the cloud to our devices. So how it can be possible? Now if you are observing this, here we have the input as a sensor mode. Okay, the sensor mode, we can have varieties of analogs and digital sensors. So I told you that the IoT is having three important parts. One is the input part, intermediator is nothing but your IoT development board, and output is nothing but an actuators, isn't it? So for input parts, there are varieties of sensors are available. So without sensors, IoT will not work properly. To work IoT properly, it should have the balance of or support of the sensors. Now you might be aware about varieties of sensor, ultrasonic sensors, then your some technologies. Okay, so here this is your input part. We require certain sensors. It will measure the parameter of the physical constraints. Okay, and it will process that data to the processor. Now suppose I will be using here certain boards, suppose node MCU. So node MCU is a kind of embedded device which is capable of processing your data, and now after processing it, after extracting the relevant important information from the raw data received by the sensor, it can be transmitted that data to the gateway via certain wireless enabling technology. So here we can use certain wireless enabling technology. Here it is shown a Zigbee protocol. We can use here Bluetooth protocol. We can use here Wi-Fi protocol, WiMAX protocol, isn't it? There are varieties of protocols are available. With the help of RF wave frequencies, we are simply broadcasting the data from the source to the your gateways. And this gateway is nothing but it is an intermediator between your device. So this is nothing but your sensor mode is nothing but your remote device. This is a smart device. Your smart device should have the interface with sensors, okay, the processors, and it should have at least single wireless enabling technology, isn't it? Okay, now we're going to discuss again, suppose what happened if we design a certain board which is capable of sending and receiving the data over IoT networks. Now suppose there are two different aspects are there. In one aspect, suppose I am using node MCU. In other aspect, suppose I am using Raspberry Pi. Now take an example, your node MCU is only sending and receiving the data via only Wi-Fi, isn't it? But your Raspberry Pi is having two different wireless technologies. One is a Wi-Fi, second is a Bluetooth. Now if your Raspberry Pi wants to send and receive the data using Bluetooth, now this particular Bluetooth technology is not available onto the node MCU. So the communication will not be possible. So what we want the heterogeneity in your device. Means once you have designed this IoT development board, it should have all the different types of wireless enabling technologies integrated into a single board, isn't it? If your any device having suppose Bluetooth, now your device should be capable of exchanging the data using the Bluetooth. If it is having a Zigbee, your device should have a Zigbee protocol inbuilt. Okay, so in this way we can create a huge processing and very tiny kind of processor or IoT mode with the help of different wireless technologies. Okay, so one example is given showing here Zigbee protocol, and this gateway is nothing but your wireless router. Okay, this gateway will be considered as it is a kind of a syncing node. Syncing node means it will always getting the information from the sensor mode. Whatever the data is processed by this sensor mode will be transmitted to the gateway. Okay, just like we have the gateway of India. Okay, it's a way through which the people can go, and that can also coming from different countries. Okay, traditionally we were using that particular gateways. Now today we are using for different purposes as a monuments, isn't it? Now the gateway is the same kind of thing. Whatever the packets are moving from one local network to the global network, and from the global network to the local network, vice versa, then it will act as an intermediator. So all the policies are, we can configure it, and based on that it will going to filter out few protocols or packets, or it will going to pass certain packet, depends on the configuration done. Got it? So this is called as an intermediator device, that is IoT gateway. Now after getting the data received by the gateway, it will now transmit it to the proxy server. So proxy server is again a kind of intermediator, isn't it? It will going to communicate with your www, that is your internet actually, and it will getting certain instant replies from that particular internet. So every time your device cannot communicate with directly to the internet, it will act as again a kind of intermediator, and next time certain amount of data is stored in the proxy. So even though if certain data are required by the sensor node, okay, or this processor, immediately it will be getting from the proxy server instead of directly going to the internet. Some of the important files or JavaScript files are already stored in this particular proxy server, isn't it? Now your request is moving from sensor mode to the gateways to the proxy mode towards the internet, and now from the internet, now it will be communicating to the cloud server via the socket, web socket. So web socket is a kind of protocol through which, okay, your TCP will be getting a full duplex kind of communication. That particular mode will be activated with the help of this web socketing, and that can be sent to the cloud server. Now what is happening on a cloud server? Varieties of statistics or analytical parts will be done, because a huge amount of data will be coming onto the cloud. So these are the scattered kind of data which is unmanaged initially. So we need to adapt or develop certain what you can say, the algorithms, isn't it? So that what is the unstructured data will be there, how you are going to make them as a structured data and stored effectively, isn't it? Just like in your computers or laptops, we are having a defragmentation kind of tool, isn't it? So defragmentation, what happened, what is the scattered data will be there, once you defragment it, it will be stored in a proper way sequentially, instead of allocating the memory or utilizing the memory randomly, it will sequentially, it will store it, isn't it? So varieties of tools, varieties of algorithms are available on a cloud, so that we can get the actual proper performance of your application. Got it? So this is the analytics. Now we can have the varieties of algorithms, so with the help of varieties of programming. So Python is a well-known programming method, okay, for this development. And finally we need to actuate certain outcomes or certain output devices. Now here we have, it is shown by your lights, isn't it? Suppose I am sending certain suppose this is the example of one example of, suppose a human is detected here, isn't it? Now that can be sensed by this PIR sensor or ultrasonic sensor, and now what happened, the request is going to the processor, it will be going to process that information. Now with the help of Zigbee, it can send the information here, and from through the internet, from the cloud, the actuation part is done. It can start the your light or any appliances, isn't it? Or suppose you are entering into your classroom, once your motion is detected, now what happened, that signal is going to the Google sorry, any kind of cloud you are using, and the statistical parameters, whatever the execution is done, okay, so it will start that particular appliance. Got it? So in this way is a kind of execution, how your actual communication would be possible from the sensor node directly towards the actuation part via this particular flow. So this is the one flow of explained with the help of one example. Now let us see one by one. There are 4 different layers are there. Just like if you are learning the computer networks, in your computer networks, ISO-OSI is a very popular and a basic kind of what you can say, the layer-wise structure, isn't it? So it will be having total 7 layers. Your ISO-OSI is having your 7 layer. It's a stack pointer, or is a stack through which we can communicating with each other. So in ISO-OSI, total 7 layers are there, but for IoT, only 4 layers are there, isn't it? But what are the responsibilities and roles of these particular layers? Now, the bottommost layer will be considered as a sensing layer, isn't it? So in computer networks, the bottommost layer will be considered as a physical layer where physical devices are there. In the same way, here the bottommost layer is a sensor layer. Okay, it's a physical layer also. Okay, now what is the functionality of this particular sensing layer? Your device IoT platform is interfaced with varieties of, yes, the sensors. Now, few examples are here shown. Okay, the RFID tags, your any kind of intelligent sensors, isn't it? Then RFID readers, your Bluetooth low enabled devices. You can have your wireless sensor networks, anything which will be capable of sensing the data. And we can have again various data acquisition protocols. Okay, so all things can be observed in your sensing layer, and which is capable of, yes, reading or measuring the environmental parameters and convert these change in the environmental parameters into some electrical signals. Okay, with the help of certain sensors or the transducers, isn't it? And once the certain electrical signals are generated, then it can be sent to the your IoT development board for processing the data, isn't it? And once with the help of certain wireless enabling technology, the data will be sent to the next layer. So the next layer will be considered as your network layer. Network layer is responsible for sending the packets from source to the destination. Now here what happened, the packetization will be done, isn't it? So your actual raw data is filled into certain small pieces of information, and these pieces of information will be considered as a packets. So this process will be called as packetization, isn't it? The fragmentation, isn't it? Now what happened? Now each packet will be connected. Now suppose I'm here drawing that particular small packet which will be having certain size. Suppose this a packet will be having a size of 32-bit wide. Okay, is a 32-bit wide. Okay, now what happened to this particular packet? One header is attached to it. Okay, and it is labeled with certain numbers. Okay, not only it can be labeled, but also certain encryption algorithms are implemented. Now take an example. Suppose I am sending a letter to my friend, for example. Now the content of information is available in your payload. That is nothing but your actual data, isn't it? And now if I am considering this as a label, okay, this label will be considered as your envelope through which your data is kept. And what we always do on an envelope, we can write the source and destination address of a user, isn't it? So that postman will easily understand the letter is coming from whom and it is going to whom, isn't it? So why we stick that particular envelope? So for providing this security. In the same way, in your networking or in IoT, this particular labeling will be used and certain encryption algorithms are implemented so that no user can able to read the content of this particular packet. Got it? It is already encrypted. So your message should be encrypted or your header should be encrypted. So initially you need to encrypt. The different encryption methods are implemented for this payload, also for this header. But initially you need to preserve this header very effectively. So if your header is corrupted, there is no use of this message because postman doesn't know this letter is sent to whom, isn't it? So this particular message will not be sent to the destination user. So we need to first preserve this header of your packet with certain strong encryption technologies. Got it? So this is the thing about your network layer. Network layer is responsible for sending the messages from source to the destination with providing certain encryption to your packets. Not only that, in the header, there are very much important information is available, isn't it? So this is one of the example. Now what header consists of? The very first, source and destination IP address of your device. Next, the source and destination MAC address of your device. Or if your packet is fragmented, so fragmented is a process of dividing your one packets into multiple packets. Suppose I have one packet will be having a size of 10 MB. Okay, so what happen if I am broadcasting this 10 MB of packet? Suppose I am uploading it onto the internet and a problem happens at 99.99%. Then what happened? I need to again upload overall packet of having the size of 10 MB or file having a size of 10 MB. But if I divide this 10 MB file into 1 MB each, so total 10 packets, fragmented packets are formed. Now, if I am uploading that packets, 10 packets onto the internet or onto the cloud, and suppose the problem happens at 99.99, so only last packet will be lost. The previous 9 packets are already available onto the or uploaded onto the cloud. So what is the time required to upload the last small 1 MB packet is very much less. But if in previous case, I need to again upload the 10 MB of file onto the cloud, so time taken will be more as compared to the time taken in a second case. So always the packets can be fragmented, isn't it? And with the help of packet switching, we are sending the data from source to the destination. Now, if you are talking about the switching, is one of the what you can say responsibility of your gateway, isn't it? So packetizing. So I am talking about the network layer. That's why here we can have the device that's a router or Wi-Fi router plays a very vital role. Okay, so packetizing is nothing but just adding the raw data and labeled it and encrypt, provide certain encryption algorithms. Got it? But now if I'm talking about the switching methodology, now traditionally we were using circuit switching methods, isn't it? Circuit switching method in telephone exchange. What is the circuit switching methods? Generally, initially, if source wants to connect to the destination, first the session should be established first. So certain signals should be sent so that whatever the sources are available in between, what happened? Those are reserved. And once the total sessions or the resources are reserved, it will establish a link from source to the destination. Once the establishment is done, then sender can send their data to the destination. And once sender successfully transmitted the data to the receiver, then what happened? Tear down phase will occur. Means whatever the resources are reserved earlier, those can release their connectivity or their connection so that other user can occupy and reserve them. Okay, so that was the kind of what you can say, the property of your circuit switching methodology. But now we are totally adopting a new technology that is nothing but your packet switching. So what happened? Your actual huge amount of packets are fragmented and very small pieces of data or packets are broadcasted into the network by labeling it, isn't it? And each and every packets are moving towards the destination randomly by choosing the shortest path in between source and the receiver, or the availability of resources available, and they can be gathered at the receiver randomly. So with the help of labeling, we can reassemble them and then we can play the content automatically. Okay, so this is nothing but your packet switching. So circuit switching and the packet switching. So in your internet, in your networking, we are using packet switching. So the delays will be less. Otherwise, if you are using a circuit switching in internet, it is very difficult because every time resources are available, isn't it? So we always move towards the or use the packet switching. Now third layer will be considered as a service layer, isn't it? It provides services to the user. So what is the task of session establishment or session release? that particular part will be taken care by this particular service layers, isn't it? So here, if I'm talking about, suppose here the your connection is connection oriented or connectionless. So how you can distinguish between connection oriented and connectionless? Okay, connection oriented means what? In circuit switching, what happened? First, the session is established. After this successful session establishment, source transmit the data, and after the successfully reception of the data, source can release the connection. Okay, so here three phases are observed in your circuit switching. So this is the same thing in connection oriented. Okay, but in connectionless, what happened? Without establishing the session, source can directly broadcasting their packets. So each and every packet may travel and find its own path, and it can receive at the receiver randomly and then reassemble it, and your data will be visible to you. Okay, it is nothing but connectionless. So this particular part will be covered under your session layer, isn't it? So that is nothing but your the session establishment transport. Got it? How the data can be transported from source to the destination. And finally, we can have the interface layer. That is nothing but your application layer, where you are using whatever the application you are using. Below that, we are having your application program interface, APIs, isn't it? So without, so APIs will be considered it is an intermediate or interfacing between application and to the your cloud, isn't it? So without interfacing, the application cannot communicating with your the cloud. Got it? So varieties of services will be provided by the application, depends on what kind of applications and the purpose of the application we are using. Got it? And now if you are observing on the right, this is an important aspect for all the four layers. This is security. We need to adopt or apply certain security rules or algorithms for each and every layer. Okay, so that's why it is shown vertically. Got it? So here in IoT, we are having four different layers: sensing layers, network layer, service layer, and the interface layer. Now this is a very important. Now it is IoT gateways. Now you should know the what is IoT gateway. So as I said, Wi-Fi router is a kind of a gateway, IoT gateway, isn't it? Through which the communication would be possible from the local device to the global connectivity. Okay, so let us talk about it. Now see, on the left hand side, we have the local network, isn't it? So whatever the devices or whatever the architecture, whatever the topology, network topology you are using, it is a local topology or local network. Okay, so it is how your devices are connected physically, isn't it? So that will be considered as your local network. On the right hand side, you have the global network, means it is nothing but your internet, or in your after your internet we have the cloud. Okay, so in between we have the IoT gateway. So it will act as an intermediary between the local network and into the global network. Now what should be their properties? The first one is nothing but the software. It should have certain softwares inbuilt, because it is a gateways are nothing but the kind of hardware platforms, isn't it? Wi-Fi router is a hardware device, but not only the hardware, it should have certain softwares installed into the device. So the question might be coming into the mind, why there is the need of the software in the particular Wi-Fi router? So depends on a network administrator. Suppose being a network administrator, I need to provide the privileges to different users or to different sensor nodes, isn't it? So I can provide that privileges to that particular sensors. Okay, so some sort of software is installed in your Wi-Fi router and called it as a firmware, isn't it? So with the help of firmware, you can configure your Wi-Fi router, and after configuring it, once you reboot that particular router, then it will work according to the whatever the configuration you have made earlier. Okay, so once the hardware is developed by the manufacturer, you cannot modify it, but we'll be getting a privilege, we'll be getting certain advantages if some firmwares are installed into it. So means we can now change the content in that particular hardware with the help of this firmwares used, and according to your router works or IoT gateway works. Got it? That is the first priority or first property of your IoT gateway. After that, it will be having a switching kind of technology. Switching. Now see, if you have seen the kind of Wi-Fi router, router also acts as a kind of network switch, because there are network ports, LAN ports are available, RJ45, isn't it? You might be seen at the backside, four ports are there, RJ45 ports are there, and one internet port will be there. Okay, through which if you connect your network internet connectivity or RJ45 LAN cable, rest of the computers connected wirelessly, or the four whatever the ports, network ports are there, the internet can be shared between all the ports, isn't it? Or we can create a small network with four devices connected on that particular router. Okay, so router also act as a network switch to connect the devices and form a local network. Got it? So it should have a switching mechanism. Now third one, it should have a routing functionality. Routing, there is a difference between switching and routing. Also the forwarding. Okay, the three different things are there. Routing, and what is the difference between the forwarding? Forwarding simply is what? Suppose the device will be receiving the data. Now suppose I am talking about a ring topology. Okay, the packets are moving from one device to its neighborhood, from that neighborhood to its neighborhood. So neighborhood to neighborhood, neighborhood to neighborhood, the data will be processed and it will form a ring kind of structure. But now see, it is a kind of forwarding. Okay, simply it will be forwarding the data to its neighborhood. But suppose I want to transmit the data directly to the destination system. Okay, so it is directly from source to the destination, but you can have the intermediate also. Okay, so they will be simply forwarding it, but routing is finding out the shortest path between your complex network, and it will be routing the packets towards that particular destination system. Okay, in forwarding what happens, simply it will be sending the data to that its neighborhood. Got it? So routing is different and forwarding will be different. Next one, the next property, your router or IoT gateway should have or possess the protocol conversion capability. Now take an example. At the input side, suppose you are using certain devices which are compatible with, for example, IP version 4. And on the other side, suppose you are using a latest kind of devices, those can be utilized or used IP version 6. Now, these are the two different protocols, isn't it? So you should have a kind of communication or conversion between the packet coming from the IP version 4 and if it is going to the IP version 6. Now there is a conversion. It should be possible from IP version 4 to the IP version 6 stacks or IP version 6 to the IP version 4 stacks. Both can be possible. So that can be done with the help of protocol conversion, isn't it? Again, I'll be giving one example also. Protocol conversion, take an example. We can have a concept of NATing. Okay, the network address translator. Your local IP address gets converted into the global unique static IP address. Okay, it's a kind of IP addressing conversion. But if suppose one of the application is communicating with a specific protocol and the receiver system is following different protocols, so it should have that conversion, and that conversion should be done by your IoT gateway. Otherwise, the communication will not be possible. Both the parties, both the nodes, it should follow the same kind of protocols conversion or the protocols. Okay, if that facility is not available, the communication will not be possible. Got it? The next property will be considered as it should have the firewall and VPN. Okay, so firewall, we already aware about the firewall. It is used for a kind of filtering kind of things. Depends on our requirement which packet they may cross your network or they may enter into the network. That configuration you can make it, so we can provide the security aspect to your internal network devices. Got it? And VPN, again, a kind of example. There's a virtual private network, isn't it? Now suppose I have my device in a remote destination, and I want to provide all the rights from my network. So I can be the destination of your destination of the remote device is different, but logically that device will be the part of the same network, even though it is located in different section, isn't it? But it will be providing certain what you can say configuration files, or in VPN you need to provide certain configuration, and that device will be logically the part of your local network even though you are sitting in different locations. So it should have these facilities, firewall and VPN. Next is a very important, it should have a security aspect, otherwise anybody can hack your IoT gateway and it can modify the changes also, done the changes by modifying it, isn't it? So security aspect is very much important, not only because if you're having a Wi-Fi router, we'll be getting certain Wi-Fi passwords. Okay, so Wi-Fi password is one way. Other ways we can provide a dual security by storing the MAC addresses of your devices, so that if the user knows the password of the Wi-Fi, but if the MAC address is not stored in the devices or gateways, the communication will not be possible. Both the credentials should be stored in the gateways, isn't it? Then only access can be given or access can be denied. Okay, so this is again one of the security aspects. So every gateway should have security aspect. And finally, it should have a processor. It should able to process your data. It depends on the configuration you have made, isn't it? And this can be done wiredly or wirelessly. Your local network can be connected to the IoT gateway with the help of wired communication, that is your LAN cables, or with the help of RJ45 ports. Okay, and also for the global network. Okay, so these are the some of the important properties of IoT gateway, what it does. Okay, what are the different properties it should have, isn't it? Or what are the components of IoT gateways? Now the question might be asked for 8 marks regarding what are the different components available in IoT gateway. So you need to draw this particular figure and explain each part, the functionality of each portion of the IoT gateways.